we now move on to the circle theorems, which may or may not turn up on the exam paper. They've been there on every exam bar one, so there is a chance they might drop off the list. These are very important theorems, and what you've got to do is learn them all, because unless you learn them all, you can't deal with them, because the questions tend to involve a mixture of the theorems, and unless you know them and know them well, you'll just look at the picture and won't be able to pick out the bits you need. There are 4 circle theorems that do not have tangents, and there are 3 circle theorems that do. So the 4 that do not have the tangents, 2 of them have the middle in. So the one that looks like an arrowhead, the idea is that the angle at the center is twice the angle at the circumference. And what you've got to be able to look at there is the various ways they can do that. And it can look very different from the arrowhead. The easiest one is the semicircle theorem, where any triangle drawn off a diameter, the angle at the circumference, not on the diameter, will be 90 degrees. That's the semicircle theorem. Cyclic quadrilateral is easy, as it's the only one with 4-sided shape in it. And the opposite angles in our cyclic quadrilateral need to add up to 180. The other one is the same segment theorem, where if you've got a triangle ABC, if you think of the point C being on an elastic band and you move it anywhere in the segment that it's in other words, it can't go between A and B, then the angle C dashed will be the same. So angles subtended from the same arc in the same segment are equal. Thank you. Then what we've got to look at is the 3 tangent ones. A tangent is a line that just touches the circle at one point. The radius is the line from the center to the circumference. Where a radius and a tangent meet, it's at 90 degrees. 2 tangents to a point are of equal length. Now, if we combine this with the first theorem, we can draw lines from the center of the circle to where the tangents meet the circle, and we create a kite that's got 2 right angles in it, which means the angle at the center and the angle at the pointy bit outside the circle have to add up to 180. The last one is the alternate segment theorem, where if you've got a tangent and you've got a triangle with a point just meeting the tangent inside the circle, we know that the 3 angles created by the triangle on the straight line, ABC, must equal 180. But it turns out that the angles in the alternate segment are equal. So C equals C dashed, A equals A dashed. Doesn't come up that often, but when it does, you've got to be able to spot it. Learn the 7 theorems, you're fine. The one that actually isn't there is the isosceles triangle, where any triangle coming from the center of your circle is going to be made up of 2 radiuses. Because of that, it's isosceles. And so it's one you've got to be able to recognize. So you must be able to recognize your isosceles triangle. Thank you.